Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfarika Maisara binti Mu'minin, and with my metric number is 301199. So I am presenting this video to explain about my proposed design for the secure network architecture for a fictional financial planning firm, SecureFin Advisory. So their business relies on handling extremely sensitive client data. So my primary goal was to build a network that protects this information using core security principles. Okay, so here you can see we don't have one single wall, but multiple layers of security. Starting from the left, we have the untrusted internet zone. All traffic first hits our primary gatekeeper, the ASA 5506 next generation firewall in the perimeter zone here. This is our first and most critical layer of defense. Behind the firewall, the internet network is segmented for safety. We have the general employee LAN and, most importantly, the highly restricted secure server LAN, which isolates our critical database. And finally, here we have the DMZ, which hosts our public web server strategically separated from our internal system. Now, let's talk about how and why this design is secure. First, my firewall is configured with a default DNI policy. It blocks everything unless it's explicitly allowed. This embodies the fail-safe default principle, it preventing unauthorized access by default. Second, I operate on a zero trust model in this design. So I never assume trust. We never assume trust, even from inside the network. This is achieved through these two main things. The first one is security levels on the firewall. Traffic from a lower security zone, like the DMZ, can automatically access a higher security zone, like our secure server LAN. So, the second one is strict access control, RBAC. We enforce the principle of least privilege. For example, the financial advisors can access the database and VPN, but the support staff can only read the specific files only. They get only the access they absolutely need and nothing more. It have limited access. Third, we secure all communications. Remote advisors must use an IPsec VPN with multi-factor authentication (MFA). Our web server uses HTTPS and we manage devices using SSH, not insecure protocols like Telnet. This protects data from being intercepted. And finally, security isn't a one-time setup. Our IT admin proactively monitors the network and applies regular patch, especially to the critical systems in the secure server LAN. This ensures we can detect and respond to new threats. Okay, now let me quickly show you how this is implemented in Packet Tracer. Okay, so here, if I open the ASA 5506, you can see the interfaces are assigned different security levels. 0 for the outside, 50 for the DMZ, and 100 for the inside. This directly enables that zero trust traffic flow we discussed before. Alright, so here, a workstation in the employee LAN. Okay, now let me quickly show you how this is implemented in the Packet Tracer. So here, if I open the ASA 5506, which is our firewall, you can see the interfaces are assigned different security levels. 0 for the outside, 50 for the DMZ, and 100 for the inside. This directly enables that zero trust traffic flow we discussed before. Second one, for the employee LAN, a workstation in the employee LAN has its IP settings configured correctly for its statement for the 6 PC. So this practical setup in packet tracer mirrors our logical design and validates the security controls we have put in place. So, for the conclusion, the network architecture for secure fin adversary isn't just a collection of devices. It's a cohesive system that weaves together principles like defense in depth, zero trust, and least privilege into a resilient and practical events. This design effectively protects sensitive financial data against modern threats while providing a flexible foundation for the future. Thank you for your time.